Jim said, and thank everybody for joining us today. I'm the lead chair of the Licensing Executive Society in New York, and with my compatriots and colleagues at NYTBF, we've sponsored, this is about the third one that I can recall, and there's one coming up in September also. While we don't have an official title, the idea for the September meeting is how to make New York City a biotechnology and a technology mecca, which is something that a lot of people are working for. And we have so far a very distinguished panel that's going to be participating in that. LES on its own will be holding a meeting, not a formal meeting, but maybe a fun meeting on July 19th in Bryant Park. And we are collaborating with the New York Biotechnology Association, excuse me, and we expect 150 to 200 people to be joining us that evening. It'll be primarily, if not exclusively, a networking meeting. And Jenna McDonald from Fox Rothschild is one of the sponsors, and we appreciate her help and her collaboration and cooperation. It's something you should make note of. We'll be sending out notes to everybody, but July 19th should be a real fun event. Unlike my test, we don't take the summer off. We're working straight through. Let me introduce the moderator of tonight's meeting. Eric Vieira is currently the Assistant Director for Mount Sinai School of Medicine's Office of Technology and Business Development. Prior to joining Mount Sinai, Eric was the Senior Biotech and Pharma Analyst at Majestic Research, an independent equity research firm. Earlier, Eric was an Associate Biotech Analyst with Rodman & Renshaw, and then Lazard Capital Markets as a Specialty Biotech Analyst. He has a PhD in Developmental Genetics from NYU School of Medicine, and a BA in Molecular Biology and Biochemistry from Rutgers College, Rutgers University. Eric Vieira.
Thank you for all attending this event tonight. It's a pleasure to be here on a topic that I find dear to my heart. It's something that I've been exploring for the past few years, and I think it's a really exciting growth area. And so I'm going to try to set the stage for you all tonight to really understand what our agenda is. It's great to see these two institutions coming together to present this, because I think we are going to need people from many different sectors and disciplines to come together to deal with the problems that we're going to face in this realm they call big data. And I hope tonight we have an initial discussion about what big data is and how it potentially could help us all in the life sciences and in healthcare. So I will start off with a few introductory remarks. We'll open to our panelists for a few remarks as well. And then really, I want this to be an interactive event. This event is being streamed live online, so we'll hopefully have some participation online. So we'll get them for questions if they have them. But please stop at any point if you have questions, and I'll be looking to you to keep this conversation going with our panelists. Okay. Big data. So just some sound bites on things that I've found in my investigations in this area. It's been estimated that the market for big data technology and services will reach $16.9 billion by 2015, up from $3.2 billion in 2010, according to a research firm IDC. Now that's a 40% growth rate per year. Now you can understand why VCs are running to health IT in this market versus therapeutics. To get that type of return, or that potential return, is significant. Okay, companies and institutions have moved from storing gigabytes to terabytes to petabytes to exabytes. And I had to learn what an exabyte is, and that's what I've come to know as 1 billion gigabytes of information. And a lot of this is due to this tremendous run onto digital data generation. And we're seeing it both in the life science space as well in social media, if you think of the likes of Facebook and Google. The World Economic Forum last year declared data is a new asset class. Okay? And when I hear that, it brings back to me my memories of working as a biotech analyst on Wall Street, where once an asset class is established, it's time to figure out how to buy it, sell it, trade it, and make money from it. Okay? And hopefully do it in a way we'll all benefit from it. And in what sector do we need value creation to take most in the most immediate of ways? It's healthcare. Okay. And when I say healthcare, I include the life science research arena, because it is from understanding what we are fundamentally at both the systemic and cellular level and the etiology and progression of disease will we ever find ways to live healthier and more productive lives. I'm excited by this march towards quantification, partly due to my personal proclivities for numbers and telling stories through visualization. This won't be easy. Big data is definitely not the only solution, but it has the potential to have significant impact on how we do science, run businesses, and live our lives. A report by McKinsey & Company last year estimates that, and this may be a conservative estimate, that if the healthcare industry, including the life science arena, can use big data creatively and effectively to drive process efficiencies and provide better quality care, more than $200 billion can be saved in the U.S. national healthcare expenditures, which right now totals something like $2.5 trillion. Okay. And finally, I will add that there's no place better suited for creating value from big data, particularly the big data of healthcare, than New York City and New York. We have multiple major healthcare centers within a walk, a subway ride, or a train ride away from each other. We have population and patient density like no other place on earth, and professionals who have deep analytical expertise, though not many are currently working in the healthcare sector. Most of them are on Wall Street. If we can just cross-pollinate across sectors, there's no reason why New York could not become home to the Bloomberg/Google/Facebook of healthcare. But it's not without its challenges, and I think we'll get to those tonight. The data cannot exist in silos. Along with the physical infrastructures that this could probably be done through clouds, we need to create opportunities and incentives for data sharing between institutions and organizations to exploit the diversity and depth of data. And we need policies to protect ownership, IP rights, and privacy. We need to understand how to leverage big data for value creation in the life science and healthcare industry. This is where we may learn from a few things, including things not to do, from our quant wizards of Wall Street. I believe it's time for these folks, these guys and gals on Wall Street, to get their hands dirty with a new data set. And healthcare life science data is plentiful, growing exponentially every day as EMR and EHR systems are being integrated into the process and culture of our medical centers and research organizations. Further adoption of medical and life science data digitization, storage, management is necessary. It has been estimated that healthcare providers discard 90% of the data they generate every day. We need to start recruiting, retraining, and educating our staff and students. Being a product of the biomedical education system, I can tell you for a fact, when I was going through my PhD, I didn't take a class in statistics. We didn't learn about how to run a clinical trial. I think those things need to change. Okay? And I do not mean we need to send everyone back to school for a PhD in statistics or artificial intelligence, but we definitely need more executives and managers who are data literate. Finally, I'm not alone in noting that it's easy to collect data. It's a much harder job to make sense of it all. New tools will be needed to make all this data more accessible and actionable in various settings, whether it's to help inform the next experiment, assist in making go, no-go decisions on a drug candidate, or to aid in the choice of the right therapeutic strategy for a patient. I hope the panel tonight, which is the result of a cross-pollination between New York City's MIT Enterprise Forum and the New York City chapter of Licensing Executive Side will serve as a call to arms and incubator of ideas for further development and the implementation of big data into the fabric of our professional lives. It is with that I'm honored to share the stage with some practitioners and facilitators of big data projects. And I'd like to introduce you to those members of our panel. So immediately to my right is Louis Cullman. He's a partner of K&L Gates, and I want to thank them for providing the venue tonight and the wonderful refreshments that we had in the pre-event reception, and please join us for the post-event reception afterwards. Louis Cullman comes from Orange County, in the K&L Gates out there, specializing in intellectual property. You have his bio. But what's important and interesting for tonight is that he's actually also the primary outside IP counselor for the Bill and Melinda Gates Foundation's Global Health Program, where he creates policies and procedures designed to facilitate data and information and material sharing between members of a multinational consortium comprised of academic and industry partners. And I think that's going to be important if we can really bring this potential of what big data can do for this industry to bear. Next, we have David Greenwald, who also isn't local, comes from Boston. He's the co-founder and manager of Relay Technology Management. So he'll give us a little introduction to his company, but he is truly putting big data into action in the life science space. So it's great to have him as someone who's taken the plunge and trying to deal with these challenges, and we'll hear from him how it's going. And lastly but not least, we have Wanmei from Oracle, who's really coming in to provide technical and business support for folks in the life science and health science space. We need the folks of Oracle to be supportive of our efforts and to help us, because that expertise, both the technical and the business side, I think we can't do it alone. And Oracle and what they have can provide that means of getting to where that potential value may lie. Wanmei is also coming from Boston, but she's an alumni at MIT and also City College, so it's great to have her back in New York. Okay? So this panel, once again, alludes to the fact that there may be expertise in a lot of cities, and I think we can build it here as well. And so with that, I want to start off the questioning to Wanmei, because she's dealing with and has been dealing with this concept of big data. I think we truly need to define what is big data. I did a search on the New York Times website, just putting in the search terms, big data, and it pulled up 1,200 articles in probably the last 5 years. That's amazing. So obviously this is a topic that is of interest for many people in many sectors. And so I think we need to really understand what is big data in life sciences. So I'll open that to Wanmei to give a few remarks. And then I want to then bring it to the other panels of saying, what does big data mean to you in your sectors? Thank you.
Thank you very much. It's definitely a great honor for me to come to the panels with the speakers here and come back to New York City, which I grew up actually for high school as well as college. So about the big data. Let me give a little bit background first. So as Eric mentioned that I'm working at Oracle right now, and I'm in the healthcare life science global business unit, which is kind of like a small company within the big Oracles. So we have our own developments, all the QA, sales team, etc. So we have our own P&L. So our main service is to develop software for healthcare institutions, payers, health insurance payers, as well as life science companies such as pharmaceutical companies and biotechs. So what I'm going to tell you about is some of our new work and my understanding of big data. So what we see is these days, there are a lot of big drugs in the market, but they actually have a really limited effectiveness. So,
excuse me, would it be possible for you to use the mic?
Oh, okay, sure.
Thank you.
Okay, so it's better now? Yes. So we see that there are many drugs out there in the market, but with very limited effectiveness. So for example, some of the drugs only have, like the beta blocker, have only like 15 to 25% in effectiveness. That means for 100 people with the heart failures, if they may not be suited to this drug, so it's like 75% of them may not be suited to this drug. But if they are still, the doctor still prescribe this medicine to them, that means they're not only prolonging their sufferingness and not helping them, but also they have to go through the side effects that by taking these medicines, right? So what we are aiming is, what we see that in the market nowadays, we see the promise of the molecular biomarkers. So if we have these particular gene mutations or these particular types of methylation in another genes, you probably should take one drug versus the others. We see a lot of promise from this kind of personalized medicines using the genetic biomarker to determine what kind of medicines this person should take, as well as using these biomarker informations to design targeted medicines so that you don't need to take this drug if you have a particular biomarker. You have already have in silico studies showing that it's not going to be effective to you, something like that. So we do see the promise in the markets, and people have significantly invested in this area. But in the last 10 years, actually, these personalized medicines kind of concept have gone through some roller coaster. 10 years ago, it was really high in them. Everybody was expecting that that is the next thing. But in the past decades, it kind of like dropped down a little bit. And there's not much progress. So what we see is the difficulty of our customers having is, one of the difficulty is how to use the information that they already collected. So right now, they usually have information locked into different silo storage, like they have a EMR system having the patients, medical records, and then they have another lab system having the diagnostic test information, and then they have, within the institution, they have a research arm that only recording the molecular biomarker, which is not utilized in the healthcare setting, and the healthcare setting data are not going to be utilized in the research area. So we see that there's silos and the data are there, but they are not utilized them well. So our goal as a IT company is to enable this, to make it, to unlock the data, to make data transparent to multiple applications, and also as well as letting the physicians, not only the IT folks, the physicians to be able easily access the data, like within a really few quick recognize, oh, this patient have biomarkers A, B, C, and those are the recommended medicines that we found that will be have some kind of guidance, not necessarily replacing the physician per se, but give them some information, more information in their practice. So that comes to our recent work in the translational research area is we recently launched a product called the Translational Research Center. The goal is to unlock the data and put it into a centralized space and let our customer to easily do the data minings of the data. Some of the data there is like petabytes, hundreds of petabytes of data, to make sense out of it, to understanding what kind of biomarkers are the one that causes, is actionable, rather than because in the human body we have millions of variants compared to a reference genome. So which one is the one that have causing the actions of a particular disease, or combination of the biomarker causing the disease. So this is our goal, the Translational Research Center, and we work with. We know that because this is a really specific domain area, as an information technology company, we won't be able to design a product that can definitely fit into our customer, including the healthcare sector as well as the life science sectors. Needs. So what we do is we work with 6 partners, including the Life Cancer Institutes in the Oregon Health Center, the Innova Health System, Merck, Roche, and Moffitt Cancer Center, and the Erasmus Medical Center in Netherlands. Together, we work with them to understand what is the exact use case they want to solve, and we use them to design the system and build a user-friendly application for the physicians and scientists to easily navigate the complex data that under the applications. So that is my thoughts about the big data.
Great. So,
Hi. Excuse me.
Yeah.
Can you give me an example of what kind of questions or data that is actually shared between Merck, for example, and Roche, as well as the hospitals?
Sure. I mean, I cannot say that literally. What
But
example?
an example
I can
of what
give you
kind of
example,
data,
yeah.
because we all know that they are essentially competitors, so how are they coming together to work out this problem?
I see. So when we work with them, we don't literally take the intellectual properties coming from these two companies. What we do is what type of use case instead of what exactly the use case. So what the type of use case we hear a lot from our customers is, I want to find patients diagnosed with non-small cells carcinoma, which is this word can be changed to some other disease, right? And with mutations in the EGFR gene, this gene can be changed to another gene, but without any copy number gain in another gene. So what we get is, we get this type of use case, which we can substitute any of those parameters in this use case, and then we do a system to easily help the physician to navigate that. So the physician can choose the genes, whatever gene that he or she is interested in, and to find those patients and then evaluate what kind of response those patients has with respect to medicines. So which can be another parameter that they substitute. Yeah.
So it's results, it's clinical results that they're sharing.
It's not a clinical result they're sharing, it's the type of use case that we gather with them. And they actually, the clinical use case that they have, the type of use case they have are rather similar. Yeah, they're always looking at which biomarker is the effective, is the actionable one. Yeah.
So let me try to clarify this question. So it seems to me what you're looking at is that a pharma company would come in and ask a medical institution, do they have patients of this class? And so they're essentially not sharing the data, but they can open up their internal data set with that query coming in from the pharmaceutical company. And then the academic institution or medical center can say, yes, we have X number of patients, and then I guess they can create an arrangement where those patients could then be part of the clinical trial. I assume that's what's happening. So there isn't really sharing of specific personal information, but it's, do you have these individuals, and do you have a data warehouse that exists to help identify those specific cases? And I assume that's what the use cases are.
Yes, those are the type of use case that we get it from them. Yeah. But we do not get the data.
Just have another question, and that is, with biomarkers, so I understand I'm not a scientist. If somebody has the same form of liver cancer, do they have this, 2 or 3 or 4 different people have the same biomarker? In other words, are the biomarkers consistent with the disease from person to person? Is that
So I would say that
The question really relates to, it's a general question in regards to biomarkers and how you identify patients. So if someone comes in with a particular disorder, would they have the same biomarkers? And I answer case by case. There's different diseases are highly heterogeneous. So you can have heterogeneity within a tumor of an individual patient. So I think it's hard, but there are certain markers that give increased, there are defining markers for particular types of cancers, and then that would dictate which treatments you can use. We saw that with the KRAS mutations in certain cancers, and if they have the KRAS mutations, you would use one particular therapeutic regimen over another. So there are certain defined classes. Same thing with the HER2 positive for looking at Herceptin use in breast cancer.
So yeah, in another word is one type of cancer may have multiple different genetic biomarkers, vary from patient to patient. Also, right, different cancer, they may share the same effective biomarkers as well. So in some sense, I think the field is also transforming the understanding from anatomical way to define cancer to using a biomarker way genetic way to define a cancer.
But I think you bring up a very important point with the idea of biomarkers, because there are biomarkers being generated all the time, and there's such a diversity within the diseases and within the patient population. And this is where I think we're getting at the point with using this area of big data, which is generating large amounts of information, collecting as much information we can about the tumor, about the patient, and integrating that with all the information and data that exists about how you treat a particular tumor based on research that's being done at the medical institutions. So it's this integration of the research arm, of identifying biomarkers, making an understanding of how to use those biomarkers to identify a particular tumor, and then is there an actionable item attached to that, in which I mean, is there a certain drug I should be using in this patient versus another one because it's been shown to be effective in that type of genetic makeup of that disease or tumor.
Eric, I don't want to take my
Yeah.
time, but I have a follow-up question. There's some other people want to ask you. So I could have a biomarker, and you could have a biomarker. Same biomarker, but I could get sick, and you could get the same biomarker.
Absolutely. And there's a lot of issues that can come into it. And most biomarkers give a relative percent of the possibility you may develop the disease or you may respond to a particular therapy. There's not many biomarkers that say 100% you'll be affected with this drug. No, that's an important point. I'd like to move on to the conversation now because I think this idea that was brought up about different institutions and different organizations wanting to participate together and share information. I think we have to think about some of the legal ramifications, and Lewis can talk about how he understands big data in his world and give us a few remarks on some of the policies and legal issues that he had to deal with in order to get some of these academic industry partnerships to work.
Thank you. It's interesting because what I'm seeing as we start to build more and more complex consortia is that we actually have an effusion of data coming in from different sources, commercial sources, academic sources. And they all have different types of concerns and considerations on how they're protecting their data, who accesses their data, what is used, what that data is used for, and then who owns the outcome of the data. I'll drill down to one specific example that's interesting in a recent consortium that's been put together by the foundation, looking at malaria as a disease. And looking at data that involves both the epidemiological as well as therapeutic data in treating and preventing the disease. And so we're looking at a very diverse sources for our information. We are looking to climatologists for data around the world. We're looking to, of all places, a great source of data for climatology and migration are the airlines. The airlines have tremendous sources of data. They've harvested this data for decades, and it's sitting there in data silos. And we have to try to access it from them, bring it in, merge it with data that we're getting from academic sources, standardize it so that it can be used. And we have to deal with the concerns that are brought up, like privacy. We have to make sure we have to take patient identifiers off or travel identifiers. We have to remove any of that type of information from the data. We have to assure that the data provider, that the data is secure. And then on the other hand, we also have to assure other entities that the data that will be used, if something results from that, there may be a commercial exploitation of that data resulting in intellectual property law rights. And above all, and most important to my client, the foundation, is what we call global access. We want to get the results of the data out to the scientific community for broader dissemination and consideration as rapidly as possible. We don't want it encumbered by legal entities. So we try to structure agreements that are rather complex, but yet in simple to institute because they provide the protection for the individual, they provide assurances to the data provider and to the data user that their intellectual property rights will be monitored and looked after, as well as we're granting assurance to my employer, my grantee, my grantor, that the data that results from that will serve the global access need of getting the information out to the general public. That's just kind of a sampling of the complexities. And what's amazing is just the huge amount of information that's out there and the sources it comes from. And then finding the very talented modelers who can take these data sources, build the mathematical models necessary to analyze myriad parameters so that you can answer a question. You might want to know the probability of patient X contracting a particular form of malaria at a particular time of year, at a particular time of day, at a particular geographical location. You might want to know the probability of which exact mosquito is going to be the one to bite. The data's there, believe it or not. We can follow one mosquito around the world. We can tell you exactly who he's going to bite and when he's going to bite, and the probability of him having a parasite. All right. We can also tell you exactly that strain of malaria, what the probability is. It's going to be treatable with the current therapeutic regimens. If the data's there, it's trying to get it together, merge it, mine it, model it, and then try to make sure everybody's comfortable with the use of that data.
So what kind of challenges have you faced when trying to get these folks? What has been the sticking point with executing these types of alliances?
Well, you have a lot of industrial and institutional and academic policies that are already in place and have been carved in stone. And you have to try to get these technology transfer offices, you have to try to get corporate structure, you have to try to get individuals and organizations to try to come together on an agreeable set of terms. I mean, we have to look at the NIH, the WHO, United Airlines, many of the big extermination companies that provide vector control. They all have commercial concerns. They all have ways they harvest, mine, and control their data. And they all have concerns about how that data is going to be used. And so getting them just to agree on a standardized set of forms and trying to get everybody's concerns kind of centralized and assuage the worry. The overall, what we're finding, and it's really fascinating, is that overwhelmingly the number of people want to help, they want to work to try to solve a common goal, but they don't want to feel as if they're a victim, that someone is taking something from them and they're not getting what they would consider to be either their attribution if they're in academia, or perhaps their financial consideration if they're in industry. Or they just don't want to see their data as misused, mishandled, misrepresented, or published in a way that diminishes the value or causes any kind of, well, bottom line is we have to worry about the egos involved. There's an awful lot of people. So I think there's all of those concerns. And trying to get, I have to deal with different cultures. I have to deal with different countries, different legal systems, in trying to bring all those people together under one document so that we can load all that data into a silo, allow the modelers to access and use it, and then govern somehow the outcome. And we're really big on the quid pro quo. If you're going to go in there and take our data, we want something in return. And it doesn't mean it's not money necessarily. It's quite often what we want in return is more data. We want the results of your data. We want your model. People aren't always willing to share those things. And so, that's another problem that we have. We have all this great data. We want people to use it. We want people to publish on it. We want modelers to come in. But, we also expect people to contribute something back to the system. And that can be problematic. And some of the large data processing centers that we rely upon also have issues with us using their computing power to do it, because it takes an unbelievable amount of computing power. I believe right now, just on that one malaria disease project I talked about, we have two deep blues running basically 24/7, and they can't keep up with the modelers or the data. So that's just kind of a sampling problem that we're running into.
You brought up a great point, and I think it relates to my initial remarks, that data seems to be an asset class, and if people are willing to share data and receive data in exchange, I think that's a realm that I think could be really explored. It truly is a currency, and so I don't know. We do have a lot of folks from the tech transfer world in the audience, so I wanted to open up to those folks to see what they're thinking, and have they had any interactions with response to using big data or using data as a currency in their negotiations. And Barbara, do you want to talk? Sort of point you out in the crowd.
No, I have not had that opportunity, but were I to have, I think I'd be pretty hard-nosed about it.
You would be.
But another a question I have, Chip, is that a lot of the funding that originates at the Gates Foundation, I mean, you really have the provider of the funds that allows much of the work to occur and happen and generate data. So does that give the foundation a greater, I'd say, bargaining chip when you look at the who owns what and how it's utilized and who benefits from it. I mean, all of humanity. I mean, the goal is that the people who need it most will benefit. But in the short term, from my perspective, if I was part of this and our scientists did a major contribution, we would expect some sort of return other than just accolades because they have used internal resources other than the Gates Foundation resources. So I'd like to know your thoughts on that.
Well, there's a couple of things to think about too. First of all, there's organic data generation. So if a grant is funded and the purpose of that grant is to generate data, our goal is to make sure that that data gets to the public as quickly as possible. We want to vet it for scientific credibility, look to see if there's any IP that can be obtained from it so that we can create a form of currency to negotiate with it. But the principal and underlying goal is to get the data out to people who can use it. So when we fund organic research that generates IP, a condition of our grantees is what we call global access clause. There's a global access policy that every grantee will sign on to, and that global access is basically that there will be no impediments to the dissemination and use of the data that's being generated. If you don't want to play, that's fine. You don't have to take the money. But if you're going to play, that's the rule. Now, the other form of data is data aggregation. In other words, there's huge pools of organic data that's sitting out there that just needs to be mined. It doesn't even need to be generated. And that's kind of a separate form of grant that we can make. The grant would be one to create a data sanitization system where the data is scrubbed of personal or confidential data. It's then aggregated, standardized so that it can be used in the algorithms that will be applied to the analysis, and warehoused and then used. And we may give a big grant to someone like Intellectual Ventures because of their tremendous computer capabilities to house, sanitize, and store that data. That's a different type of grantee because their condition is to get the data available to the public as quickly as possible. So the foundation's overarching process and purpose is to get the data and information to the people. And that's so that I come from a little different perspective. It's a real open source perspective. So if there's an impediment that a grantee has that would prevent them from sharing something that would be even partially funded by our work, it's going to be up to the program officers to make the decision. But in the final analysis, there's going to have to be acknowledgement of global access. So what do you get out of it in return? Well, you got the money to start with, and that was your clearly we're asking for the pro quo.
I want to give David a chance to interject now and talk about how he has implemented sort of big data strategies and is creating value and disseminating and getting that information out to his customers.
Sure.
David.
Thank you very much, Eric, and it's a pleasure to be here. We're based in Cambridge, but I'm originally from New York, so I don't want anybody to start throwing things at me. So just by way of background, I have a PhD in genetics. We talked about it at the center, and I'm one of the co-founders and managing director of Relay Technology Management. We are funded by Nature Publishing Group, so we have an academic publisher as a strategic partner and funder, which is very interesting and very useful for us. And what we've done is we've taken scientific, medical, and business data and aggregated them in real time and then provide software solutions to biotechnology, pharmaceutical, as well as tech transfer organizations. And we rely heavily on our customers to say, what question I really need to ask? I want to know X. And then we'll say, well, these are the data sets that we have. What would you think if we, put something together like this? And typically that'll be in the form of an interactive dashboard or through one of our products. We just launched a product called Business Development Live, which focuses on business development and licensing, specifically from early stage biotechnology and academic institutes to large pharmaceutical companies. And I'm happy to talk about a couple examples, but I think that's kind of a broad overview on what Relay does. And we've been around for about 4 years. We've worked with, at this point, 3 of the top 10 pharmas and a handful of biotechs and tech transfer offices around the country. I can tell you, this is something that's definitely gaining steam. A lot more people in the industry are becoming aware that there's a lot of information out there, and if you want to make a good decision, you really need access to the best information, and you need it in a way that you can understand it. One of the challenges that we talked about beforehand was data visualization, and I don't want to get ahead, and we'll probably talk about this later, but it's a huge component of big data, especially in the healthcare and life sciences arena. So happy to talk about some examples of some work that we've done, and look forward to questions as well.
And David, how did you get into this realm, and what brought you into starting Relay?
Sure. So it's kind of a long story, but the shorter version of it is that when I went to get my PhD at Tufts, I was very interested in translating early stage research into therapies. And along with my co-founder at Relay, we actually founded the Tufts Biomedical Business Club. And this was a way for us to kind of network with folks in industry, both in VC and investment banks, as well as pharma and biotech. What we learned was that there's this huge discrepancy between all of the amazing work that's happening in academic medical centers and what's actually making it into the pipeline in some of these even early stage biotech companies and what's getting funded. And we were both very frustrated with the inefficiencies associated with that. We worked on a consulting basis with several large pharma companies to understand how they view the world and what some of their limitations were. And then we said there's an opportunity here to start a company which provides a service to both sides, almost like a broker, right? So we help academic tech transfer offices identify what they should be out licensing and help them identify who they should out license it to. And then in reverse, we also provide a service to biotech and pharmaceutical companies that are looking to either partner with academic medical centers or to license assets. And so in this sense, we can use the same data on both sides of the coin and act as a facilitator to, in our mission of the company is really to get better drugs to more patients faster, right? And so the way that we view that is by speeding along the business development and licensing transaction pace.
One of the questions I always have, you hear this idea of garbage in, garbage out. There's a lot of data being generated. I assume that a large part of Oracle and your work and Relay really has to do is understand the quality of that data and how do we make sure that it's valid. Because at the end of the day, if a patient's being treated based on this data, there's got to be some assurance that the data is good. And then maybe Luke to talk a little bit about this issue with liability, using all this data and making sure that who's liable at the end of the day if there's a transaction that takes place based on this data. So maybe you can talk a little bit about your experience with scrubbing the data and its quality, how you dealt with that, especially if things are, as I see, sitting in silos, getting old and crusty.
Yep.
Does data have a time life as well? Sure. It's not going to be as good, and quality is not going to be great.
Yeah, broadly speaking, you're absolutely right. Data quality is first and foremost, and we only ingest data that has the highest data quality and has high fidelity. What I would say is that the way that we create inferences between data sets is really important. And so if you rely just on one data set and you say, this is what it says and this is what it is. For instance, if you were trying to identify a researcher in cardiovascular disease at Harvard Medical School, and the person's name was Barbara Smith. Well, there might be also another Barbara Smith at Harvard Medical School that works on diabetes. So now you have a problem, right? That's it might be good data, but it's confusing. And so what you need to then do is look at other alternative data sources, such as publications, patents, clinical trials, funding, press releases, in order to make an inference to say, this is the Barbara Smith who works on diabetes, and this is the one who works on cardiovascular disease. There's also a temporal aspect. The one who worked in diabetes might have worked at Harvard Medical School in the 1980s. The one who works in cardiovascular disease might be there now. So there's little tricks of the trade to kind of get slightly higher data fidelity. But I think the overriding principle is not to rely on one data set if possible, and to cross-reference. And if you can do that in a systematic way, I think you can get from maybe 70 or 80% of data fidelity up to 95% plus. It's never going to be perfect. I think that's one thing I wanted to mention, just off the bat is it's meant to be a tool, right? So it's meant to give you an insight that you wouldn't normally have. This is what big data is, right? Is let's aggregate all this data and come up with an insight that you wouldn't get by looking at one piece of the data. And so that's kind of the solution that we provide.
So once again, it plays this issue of breaking down these silos. The more that data is opened up and shared, the fidelity of this data should improve. Maybe Wanmei, you can talk a little bit about that, is the fidelity of data and how Oracle looks at that and tries to make sure that's an important aspect when you integrated life science data with clinical data.
Yeah, definitely. Yes, the data actually tend to be extremely dirty before you scrap them and clean them and before you aggregate them. So for example, even not only combining the clinical and the life science data, but just within one healthcare organization, there are different systems and different departments. Like I know some healthcare system, half of it is in Cerner, half of them is in Epic, and they need to, and some of the system, there's some payer system, and which is not talking to the EMR, how to aggregate, how to scrap those data out, and they usually are in different coding system too. So how to normalize them and do the mapping, so to know that this ICD-9 code or ICD-10 code is really this CPCA code, to make sense of those two data points, and then make sense of it is very important. Besides cleaning the data, I think another big aspect is whatever we do to transform our data, we need to keep track of the transformations. Otherwise, it's very difficult to lose track of what has been done. So, and at some point, the regulator may want to impose some kind of regulation to understand what we have done, why we make this decision at this point, and that decision is based on data coming from two data silos. So, and we do need to keep track of the traceabilities. This data point is because of transformation of these X, Y, Z, so that we can always come back to the regulator that is the basis that we make these decisions. I think that's also very important.
So I think we're hearing a lot that there's a lot of challenges with big data, and the point of this meeting is not to focus on one, because I think we can take one of these issues and have a whole discussion all night long. It's really, at this stage of this meeting, is really to bring out these as challenges, but also for the audience to think of opportunities here. I know there's a lot of investors in the audience. I think there are areas where the value would be created in business can be formed to deal with each one of these challenges in this area of big data. And I think it's important for all of us to hear this, because this is, like I said, it's being reported on. It's on the front page of the New York Times or the Wall Street Journal. And it could be a bubble right now, this whole advent, but I think what it's really showing is there's a lot of opportunity out there, and there's a lot of growth for building tools to help researchers both in the life science and academic world to really create that value. I do want to return back to this issue of data fidelity and maybe the issue of liability, and maybe Liz can talk a little bit about that.
Well, I think liability is going to rest entirely upon what representations are made. So if you are providing a data set to a researcher or to industry, and you make certain representations about that data, then a liability attaches. If you're merely just saying, look, here's the data, here's the raw data, here's where it was collected from, and this is what we know about it. As long as you're not dealing with issues, in the healthcare sector, which is HIPAA, which is patient identifiers and identifications of that type, or if you're dealing with any form of confidential information, as long as you are not reaching an agreement and releasing the data contrary to any either contract you have, a confidentiality agreement, or law, then really there's no liability affixed to the data. It's just that it's hopefully a public sector source of information that the individual who then uses the data can extrapolate whatever he's seeking or she's seeking to extrapolate. Then it's the representation that the person makes after they've mined the data. So liability is going to follow the representations you made, the legal agreements that you have entered into in taking possession of that data.
I want to take some questions from the audience now. We're online. Over here. Stephen.
Is the goal ultimately is everybody going to compete to aggregate the biggest database? Because that would be the most useful tool? So we're going to have, and would that put the researcher in the position of having to check each database in order to be sure that they have the most accurate result? I'm not clear about the business model, the ultimate goal of the data aggregation.
So I think so with this. So I think it depends on the question you're trying to ask. right? So if you're trying to ask a research and development question, it's completely different than if you're trying to ask a business question or a human resources question or an intellectual property question. I mean, there's a lot of different uses for similar data sets, and so it really depends on the question that you're going to ask. Because I mean, it's not just one type of data that I think could be useful. So I think it really depends.
From my experiences too, in dealing with integration of data into a product and trying to use it, you know, it's really important to understand the source of that data. A lot of data is publicly available, and just understanding what that source is and knowing where you can get it, so you can keep building on different data warehouses using the same proprietary or publicly available information. So doing these types of studies, really understanding where the data is coming from and the depth of that data, especially when it comes to looking at patient records. You know, I've worked a lot with, in the past, with IMS Health and various groups who are compiling and aggregating either prescription data or longitudinal claims record data, and you really have to understand how broad that data exists. Is it representational of the national, at the national level in the U.S., or is it biased because the majority of patients are from the lower east corner of the United States, and therefore it's not truly representative of the number of cases that exist? I think we've got to concern ourselves and become, once again, data literate and what it means to have a properly sourced data set and data warehouse to ask those types of questions.
Yeah, we have, as an example, we have far more data in our data warehouse than we use on a regular basis. So we've aggregated what we thought, you know, we're going to need this, we're going to need that. We've kind of built this master database, which we thought, you know, was pretty comprehensive. The questions that we end up answering for our clients, though, usually relies on a very small subset of data. And sometimes it's the same data set, sometimes it's a couple different data sets. But I don't necessarily think that bigger is better.
I think I can see that there would be a commercial value in data sets. And so there may be a competitive industry where data sets for certain applications are being competitively grouped and scrubbed and standardized. And that creates the whole intellectual property law issue around that. Once you've invested in that data set, once you as a commercial entity decide you now have a data set that is useful to another industry sector, how do you protect that data? Because once you let the genie out of the bottle, you can't put it back in. So that's a concern that we see when we work with, sometimes we have commercial partners involved in some of the grants that we do, and they're very concerned about, you know, they want our data to be part of the healthcare solution, but at the same time, they don't want that data to get out into the public domain. So creating the type of protection around that data that you have to be able to do is both a combination of legal instruments and also a case of software coding and data management. So it's kind of a combination of all three of what we do here, from the Oracle to your company to how I would write an agreement and try to legally bind someone into how they use the data. But clearly I can see huge industry around data. And it not, I mean, we're talking about the healthcare sector here, but in almost any business sector, you know, big data is potentially hugely valuable commercial entity.
Additional questions?
So I know a lot of the heavy lifting often happens in capturing the data, normalizing the data, making it available. But I'd love to hear your thoughts from the panelists in terms of the perceived value of the presentation layer, so the dashboarding, visualization of the data, and what your experience has been for users to adopt using big sets of data based on what that front end looks like.
Great, thanks for bringing that topic up, because I think it's truly important. As I said, you know, that it's easy to gather all this data. There's plenty of publicly available sources. There are proprietary guys out there who are selling this data, but it's really important to try to figure out how to create the visualization and the tools to access that data, because most of us aren't going to be able to use the statistical methods. So I think those dashboards and those visuals that are created will make it more accessible. So maybe Dave can talk about that.
Yeah, so it's huge. I mean, I would say that you know, the front end of our application is what sells it at the end of the day. I mean, you could have tremendous amounts of data that's completely useless if you can't visualize it in my mind. I mean, you really need to be able to visualize the data. And I would say that we've got a couple people on our team who are really passionate about data visualization. and they're just tremendous. I mean, the work that they do, hearing what the client wants, and then saying, what would you think about it this way, and then building an interactive dashboard where that person can not only visualize the data and update, have it update in real time, but being able to actually ask the questions that they want and immediately get to the answer. I mean, that's really kind of where the rubber hits the road. Just having data in a warehouse is useless if you can't make sense of it. So I'm really glad that you brought that up.
I also definitely want to second what you just said is I think that is a big word these days is called democratized the data, right? So the data is out there, and if you have to require specific skill like statistician to writing Perl script or some kind of SQL to interact with database, that really just serve a really small subset of people can access the data. But for majority of the people, they just want to have a user-friendly interface to figure out the dashboard, the visualization of the data, like the scientists and clinicians. That kind of application is crucial to make it easy for them to utilize it, to democratize the data. And furthermore, these days, I do see that in the genomics sector, area, there are a lot of standards that are developed, like the formats of the data, as well as the visualization, like the UCSC genome browser, the IGV genome browser in the Broad Institutes. They start to get commonly used in the society. So I think another thing is to how to, for the industry, is how to embrace with the public efforts that is already developed and to be used. And people also get used to seeing those kind of wow too. So to use those and continue to develop and perfectionize the visualization is also very important.
I was wondering if you can talk a little bit about who owns the data. So often data passes through many hands, and at the end of the day, who has ownership of it?
Well, yeah, that's always a big question. It really depends on how you define ownership, number one. So start with, if we have organic data that's being generated de novo from a particular clinical trial, the owner of that data is going to be the sponsor of that clinical trial. On the other hand, you might have data that resides in the public domain, but it's in a dirty source. It's not something that can be utilized easily. It's the type of data we would get from the airlines. It's just all over the place. There's something there, but we're not sure. Airlines don't put a lot of value on it because they're just warehousing it. But when it gets back to be scrubbed and standardized and cleaned up and put into a form that someone can actually use it, normally ownership is going to be some sort of transfer of ownership from the original collector to the person who then puts it into a commercial format that can be utilized, and then now the person who has taken the time to put it into a commercial package, they would then be the owner of that data. Also, of course, there's a lot of data that's being gathered and scrubbed and cleaned and literally just put into the public domain. Once it's been dedicated to the public domain, it's public access. It's no longer the data that is owned by anyone, but it's the output, it's the outcome of the data, whatever you use the data for. And that creates a different ownership issue altogether. So I can look at, there's private sector data that's generated de novo, there's private sector data that is generated from public sources or private sources that have been cleaned up and standardized and adapted to work within a certain system, and then there's data that simply resides in the public domain. So I think ownership of data follows pretty much ownership of just about anything else. You have to kind of, it's intangible, but I think you can use tangible property laws to define ownership.
So for a company that perhaps does revenue cycle management, has a lot of information going through them from the hospital to payers, etc. Do they own that data? Do they use that data?
Well, if they're just it depends on. It depends upon under what terms that they took the data in to begin with. If there were no restrictions on the data that came to them, and they're not releasing confidential information that is governed by statute, then they would be considered the owner of that data pool, and they could do with that data pool what they wanted to, and they could create what any type of proprietary boundaries they want to put on that data. All right. So it's going to depend upon, again, how did they take possession of the data? Under what terms and conditions did they take possession of the data?
And so I wanted to ask a little bit about the notion of democratization of the data and think back to the genomic space. You talked about genomic and genetics, and I remember 15 years ago there were many companies with business models based on licensing sequences of express sequence tags or raw genetic sequence or single nucleotide polymorphism data. But all that information became free to everybody in relatively short time. So I'm just wondering about this shelf life and the natural democratization, natural phenomena of more data becoming apparent in the public space, and how that speaks to some of the business models we've heard tonight.
So yeah, actually, definitely bring up really good points. Like for example, the TCGA projects that run by the NIH, right? Now they have, I think the last time I checked, has about 5,000 or so samples. For each of sample, they have sequenced the tumor. Not only that, but also you can look at the expression, methylation, proteomics type of data, and put it into the public. So pretty much everybody is accessible to the publicly accessed part of the data, and then if you apply for special access permissions, usually for researchers, you'll be able to grant the access. So what we see is from our customer point of view, they also generate data in-house because of their patient, and which is, like Louis said, is part that is due to the clinical care, part of clinical care that is not part of the public data. But on the other hand, they really want to make sense of their own data with respect to the public data, right? Let's say you see a certain polymorphisms in this patient that you have no literature talking about that. You want to recheck with the TCGA data to see whether any of those 5,000 patients have this polymorphism. So I think although the TCGA data set is out there for free, but making it easy for the physician to easily check these patients against these 5,000 patients is some kind of business value that we aim to provide to our customers.
Once again, I think it comes down to creating products that clients will appreciate and get access to that data, and if there's value created in that business, hopefully it will be successful. It's a matter of how are the barriers to entry for another company to do the same. I think that's the big question. From an investor standpoint, that's what I would be concerned is how easy is it for someone to replicate that or re-engineer that same product. And so I take that point. Do we have some questions over here on the side? All right, then we'll go back to here.
Eric, one of the things, though, that came up last week, and there was an NIH meeting to kind of restructure spending by NIH and shift funds from the CAB program into different ways to use IT. And one of the big complaints that came out from the first round of speakers at that was that it's extremely difficult for researchers that aren't directly funded by the Cancer Genome Atlas to get access to that data unless you go in, you have an approved research project. It's not like we heard that you can say, okay, I've done this research on my database, I'd like to check it against that one. If you try to do that, at least from what people were saying at the NIH meeting, you can't do that right now. You'd have to have a project that was approved. This kind of public access to this database, which is supposedly very public, is essentially blocked for almost everybody that would like to use it.
Alternative conditions to access can be placed on any database.
Right.
And there are certainly means by which you can code data so that it is not readily accessible, even if you didn't get through that first layer of do you have a right to access the data. So absolutely, I mean, data can be protected, it can be excluded, and there are a lot of reasons for doing that. A lot of what the public databases we see, the exclusory limits placed on them is to protect the sanctity of the data itself, to make sure that the data is used in a way where when a publication comes out and that database is referenced, that whoever accessed and used the database used it under a certain set of guidelines and rules. And if they had any way of accessing the raw data itself, that it wasn't exploited. So a lot of that is just preserving the pedigree of the data and the credibility of the database.
Right, but I think that the main point was that these were prominent people at other research centers around the country. And they were all saying, you know, I'm doing important research, and this is an NIH database which the public paid for. I'd like to be able to check my research against what's in the TCGA database, and I can't. So, you know, they were feeling like unreasonable restrictions were being put on access.
Or were those restrictions technology restrictions, or were those restrictions legal restrictions?
I think that they're basically set up by TCGA, the project, and that it's to essentially almost silo the research institutes that have been chosen to be part of that project. And that's one of the complaints that led to the overthrow of the CA-BIG program, which was that it had a large number of universities that continued to bill NIH for building up a computing capability which was producing very little valuable research.
But do you think that maybe it's because it's in the early stages, they don't truly want to release it public because they're still concerned about the fidelity of that data? As you're building it, you've got to keep generating and bringing in more data until the fidelity is a certain level that you're comfortable for people to use and then base their results on that. That gets again to this.
But the TCGA meeting last fall suggested that the research that had been done was really just opening up the first level of what we could understand about the genome, and that if it was going to be a really valuable tool, they had to run up to 5,000 genome cases or individual genomes they had studied to something closer to 1 million or multi-millions of cases. And at that level, you'd be able to not only see the sort of surface analysis that's been done with markers, but you get below that surface to the next couple of layers down, which at a level of 5,000 can't really be discerned.
Well, I think that calls for bringing folks up at NIH to come up and talk about the program that they want to. So any more questions? Right here.
Yeah, I have a question, sort of the maturity of aggregating and building an ecosystem where I'm using sort of the example of market data that's been around for years, where you can collect data from all different exchanges through a bunch of aggregators and then distribute it through distributors and then have people doing analytics against data from any source through any distributor with any analytic. How far off is that?
You're speaking for the life science healthcare space, particularly. I think Wanmei can maybe speak to that. I would say we're at the early stages and we're not ready for that.
Is it like 5 years or 10 years? Or?
I don't know. Do you want to make some sort of projections on when they think it'll be operable? That we will have data that can be aggregated and sent out and have research done on these data sets?
I think a lot of efforts are devoted in this field to definitely democratize the data. But how long it will take, I would say that is both technologies and the legal related issue. So probably I would say the legal related issue would be an even bigger barrier than the technologies. Yeah. So yeah, it's kind of difficult to project the time.
Over here.
So just to extend the NIH thing, I think there's a converse problem in NIH that there is a consortium but everyone's not willing to contribute. So maybe Lewis can kind of give us his insights on what is that one thing that will drive people to collaborate on collaborative consortium?
I think that's a good point. How have you seen the Bill and Melinda Gates Foundation incentivizing people to participate? Or have they?
Well, they do, certainly. I mean, it's a process where it's done carefully and cautiously because, again, it's always generally fairly early stage. I think it's a common goal. I think you have to try to unite people around a common goal. So if you have a major global health issue that needs to be addressed, and you unite those people around that common goal. The problem is, on a global scale, there are so many socioeconomic issues that come into play and politics that come into play that just throwing money at a problem does not always result in a solution. We try to bring down those barriers to the maximum extent by trying to get a general understanding of people before we start the project itself. And I can take an example where we had really just 12 people around the table. Each from a different institution, each hand-selected for a particular skill set that they brought, whether they were a modeler, or whether they were a data source, or whether they were an interpreter of the data. Just trying to get one agreement. They are all united around the same goal, okay? I won't be specific, but they all had the same desire to eradicate a particularly eradicatable healthcare crisis in a particular part of the world, and yet it took over a year to get the documents together that allowed everybody to talk freely and to negotiate and to agree, because you had every institution had policies and rules, and some were very rigid and they wouldn't move, and some there were government institutions that wouldn't cooperate, and there were, so there's these myriad secondary and tertiary factors that come into play that when even you have a common goal and people are incentivized to save lives and to resolve healthcare problems, there become bureaucrats and egos, and it's amazing when you would think it would be an easy problem to solve. You're looking at 12 nice guys all wanting to do the same thing from well-known institutions, all with the same basic mantra in their charter, and yet you can't get them to agree upon whose name goes first on the paper, who releases what data. It can just become frustrating. And 17 iterations of the document later, you finally get reluctantly people to agree.
12 angry men.
Should have 12 lovely women around that table.
That was actually a generic guy. I mean, there were plenty of women there too.
Right. I wanted to follow up on the question over there about who owns the data, because I'm curious as to who owns my data. If I go into a doctor's office, is it the HMO? Is it my employer? Is it myself? And then further, is the industry kind of getting ahead of itself with regard to regulation about privacy problems?
Those are hot button questions, and I think that the answer is different in different situations. I mean, certainly, anytime I can point at it and say you're associated with that data, you own it. I can't touch it, and only you can release that data. What happens when you can become part of a huge database, and now suddenly it's depersonalized, and by no grant of yours or by any action on your part, that data is sanitized as the patient identifier. You become nothing more than digits in a database. Do you have a right to come back and say, no, wait a minute, I want a commercial proceed from the use of this data, of which I am just one of a myriad pieces of it? I don't know if that question's been clearly answered. I mean, I think the law is clear. We have to protect your identity. We have to protect your privacy. But what happens just to the raw data that just becomes an ethereal number in space? I think that data probably would rationally belong to the aggregator of the data, as long as your privacy rights are protected in it. And do you have a commercial right in that data? There's case law on tissue and cell lines and specific biologically tangible material that would be taken from you. The law's fairly clear on that. But an ethereal cholesterol level that ends up in a database looking at a biomarker for heart disease, it's hard to put a value on. It's hard to put any kind of a commercial meets and bounds around it. So it's a tough question to answer. I don't have a definitive answer for you because I don't know if there is one, but I just believe that as part of a greater database, the raw data, completely separated from you, is probably owned by the aggregator database.
So you don't think there'll be a mad run on the data warehouses? Everyone wanting to pull out their data.
Great for the lawyers who handle that case, I guess.
We've got time for a couple of questions. I did want to make sure, if we have any online questions that are burning up your computer back there. No? Anything? I guess not.
I'm actually coming from the big data of advertisement, behavioral data, like online, which is kind of not finance, but it's not health. There is a lot of issue related to your question about do not track. So if I'm searching websites, people know about me that I was actually cared about. I was searching before travel, so they would put me in advertisement of travel. So it's like a lot of collection of big data from other purposes. So in that matter, everyone collects about us data online without specific knowledge about myself. So that's a question that relates to this type of relationship of privacy, like who owns the data. But the other part is, in this world of Facebook and others, how much do you see the patients themselves contribute data, voluntarily to these big data warehouses?
Yeah, there are examples of that. It's an interesting question. There are examples like Patients Like Me, which is an organization and company that the patients voluntarily give their information. It's almost a social networking group for people with particular diseases. So they've created a business model around that where patients actively participate and provide data.
What is the name of it?
Patients Like Me.
Patients Like Me.
Out of Boston, I think, as well.
Yeah, they are. So Patients Like Me is it's a great organization. What's interesting, though, is So you've got a lot of patients, mostly it started out of ALS, the Gehrig's disease, and those patients kind of formed a group and kind of say, I'm on this medication, this is how I feel, I'm having a good day, I'm having a bad day, this is working, this is not working. What's interesting about it is that when you consider what are the pharmaceutical and biotechnology companies going to do with that data? And are they necessarily interested in it because they want to say our drug is working or our drug isn't working, and why would that be? And can we look at that patient's history and discern some insight from it? Or are they looking at the real value of it being access to those patients? And here's a really well-formed community of very specific patients. And if I'm developing an ALS drug, I would want to get in front of those patients and get as much kind of goodwill. I mean, we've seen cases with MS, HIV/AIDS, with where patients can play a crucial role in getting drugs approved. So especially with smaller orphan diseases, if you can get the goodwill of the patients, that might increase chances of getting regulatory approval. So it's interesting just to think about whether or not, I don't know whether or not the pharmaceutical companies are necessarily going to take what patients say on a website like Patients Like Me as gospel, right? So that's very separate than, oh, I think my blood pressure is high today, versus this is a blood pressure measurement that was taken at a hospital by a physician, right? So there's a difference in kind of what that data means, at least in the biopharma.
And there were efforts by Google. There was Google Health that came and went, and Microsoft still has their health vault that exists. So that's, again, people contributing their information to a data warehouse. And it's unclear to me where it will go from that point of view. So we'll have to see. One more question.
Well, picking up, that sort of takes to the sort of a futuristic question of personalized medicine. As you get instrumented with, smart devices and smart instruments where you can be tracking your behavior, your exercise, your food intake, your genomics, your drugs, and you can do detailed models of exactly what's going on and what your outlook is. One is, are there major barriers to that if people opt in to volunteering their data with measurable, with sources that are validatable for the data quality? If people opt in, is there efforts to aggregate it, and what are the major barriers?
Yeah, one of the part or sector of the group that we haven't talked much is the payers. And the payers are actually doing this. If you follow the trends with some of these companies that have created these devices to monitor your activities. One is Fitbit. When you just wear it, it measures your activity throughout the day and during the night. And I believe it was United Healthcare that signed a partnership with them, and they're now integrating that into your record on United Healthcare. So they'll be able to monitor your activity, and hopefully that comes with incentives. If I'm more active, my healthcare premiums go down. That's to be seen, but I think that's somewhere the payers are starting to investigate, is to be able to evaluate and monitor their individuals who are part of their world. So I don't know, Dave, do you know other examples of that? That's one I clearly know, and I know there's a few other examples where these payers are looking to partner with these types of companies that are tracking activity, calorie counts, and such.
There's a great book Eric Topol just wrote, The Creative Destruction of Medicine. And it does a great job of actually being very current as well, of talking. And it's very much focused on mobile devices and how mobile devices are going to transform healthcare, because you're going to be able to get all of this health data on a continuous basis from everyone, and it's going to lead to all this revolution. It's very inspiring, and I have the highest hopes for it. My personal prediction, I was going to make this analogy, I wasn't sure if it would work, but we originally thought there was 100,000 genes, right? And so it turns out there's 30,000. It turns out that a tree has more genes than a human, right? And so I think what's going to happen is we're going to gather all of this data, and it's great. We're going to have the systems for it. We're going to have all these things in place. We're going to eventually get all of this data and have all this data, but the signal-to-noise ratio is going to be so high that the really meaningful data that we get is going to be a fraction of what we hope. And so I think that that's something important to bear in mind, just that, there's an abundance of data. There's going to be even more data in the future. the limiting factor is really going to be around what questions can you actually answer with the data with a high degree of certainty that A plus B equals C, right? So I think that ultimately that's going to be it. And I think that the companies that will succeed will be the companies that not only have the technological know-how to kind of do this, but can also answer really important questions that are answerable. And so when I look around, especially in Boston, there's a ton of startups doing work in this area. And you need to ask the right questions. And if you're not asking the right questions, both commercially and technologically, then I think you're kind of doomed to start from the beginning.
Can I just follow up? Don't you think in like credit rating, the artificial intelligence, neural networks, all that stuff does amazing things with noisy data with very few data points?
Sure.
So isn't that reason to think you could do similar analysis on noisy healthcare data?
Complexity of the human body, I mean, cells, tissues, organs, molecules, versus like, did I pay my bill on time? I don't know. We'll see.
Yeah, it's good to see. Well, I want to thank the panel. This is quite informative. I hope this is a continuation, a discussion that will continue on in the future. I want to hand it off to Arno for a few last closing remarks.
Very quickly. Thank you, everybody, for attending. I want to thank KL Gates for their hospitality and your participation in this. I also want to thank each of the individual members of the panel who gave, I think, a very insightful presentation and a discussion. And last but not least, and there's going to be a reception afterwards so you can continue to mingle, continue to meet friends and associates. In the spirit of the overall meeting tonight, I'm pleased to report that 96.3% of you stayed in tune with what was talked about 84.7% of the time.